This is lesson 50, and lesson 50 is about trig equations. Okay, so I need to get my pen here, and we know that the sine of 45 is 1 over root 2. You memorized all those triangles in advanced math, and that the sine of 135 is also 1 over root 2, and they're both positive, because sine is positive in the first and second quadrants, and 135 has a 45-degree angle as a related angle, or a reference angle, sometimes it's called. Okay, the value of 405 and also 495 are the same. They have a sine value of 1 over root 2. So if we do 405, we've gone around once, and we've landed right back in the first quadrant, coterminal, right on top of a 45-degree rotation. And so that would have exactly the same sign. And if we do 495, we've gone around once, and we've gone 135 degrees more. And again, that gives us a 45-degree reference angle. So the sine of 405 and 495 is also going to be positive 1 over root 2. They are coterminal with the angle that's less than 360 that rotated to that position. We can go around twice, 3 times, 4 times, 5 times, as many times as we want, and there would be an infinite number of angles which have a sine of positive 1 over root 2. To restrict the answers to something that's reasonable, we just use 45 and 135, and we always have angles now when we solve trig equations. Our angles only are in between 0 and 360. We only look at angles that have those parameters. Okay, so this is the sine of theta is 1 over root 2. It's also positive again, so we can just write down our answers. We know it from the first part of the lesson. We have a 45-degree angle in the first quadrant. Sine is also positive in the second quadrant, and so the other angle is 135. This is a little more difficult. Okay, so we have 2 plus root 3 secant theta equals 0. We're going to subtract 2. Our variable is theta, and we have to solve for theta. So first we have to get everything else away from the secant theta. This gives us root 3 secant theta equals negative 2. Divide through by root 3, and we get secant theta equals negative 2 over root 3. Well, secant is one of our reciprocal functions, and it's the reciprocal of cosine. So if we know that the secant of theta is negative 2 over root 3, we know that the cosine of theta is negative root 3 over 2. And we have to figure out what we have here. Okay, well, cosine is negative in this quadrant, and it's also negative in the third quadrant. So 2 and 3. Our angle's rotated like that, and we make our triangle here. The negative root 3 is the adjacent side, the 2 is the hypotenuse, and this is a 30, 60, 90-degree right triangle. Opposite the 30 degrees is always the side that's 1. Okay, so in this quadrant, we've gone 180 degrees, not quite, it's minus that related angle. So our second quadrant angle is 150. This will have exactly the same reference angle. Okay, so we've gone 180 and then plus 30 more. Our negative root 3 is here. This time it's negative 1. And our angle is here, 30 degrees, and we have 2. So we have gone 180 to get to here, and then 30 more. 180 plus 30, the related or reference angle. And our answers then are these 150 plus 210. And number 3, another equation, 3 root 2 plus 3 cosecant theta equals 0. We're going to subtract 3 root 2. We're going to divide through by 3 cosecant theta equals negative 3 root 2. We're going to divide through by 3. And we're going to get that the cosecant of theta equals negative root 2. The 3's will cancel out. Okay, well, if cosecant of theta is negative root 2, this is another reciprocal function, and it's the reciprocal of sine, so I know that sine theta has to be negative 1 over root 2. Sine is negative in the third quadrant. It's positive in the second and the first, and also in the fourth quadrant. This is the sine of a 45-degree angle in each quadrant. Okay, related angle. We've gone 180 plus 45 to get to there, so our first angle is 225. Now in the fourth quadrant, we've gone 360 almost, but not quite. So in this quadrant, we do 360 minus 45 degrees to get our actual rotation, and that would be 315 degrees. It's always helpful to remember those things, okay? So I'm going to write a little chart here for you. The actual rotation, the big rotation, always equals the related angle here. The little a stands for related angle. Here, the actual rotation equals 180 minus the related angle. And here, the actual rotation equals 180 plus the related angle. And in quadrant 3, the actual rotation equals 360 minus the related angle. Okay, and then again, remember the mnemonic device. All students, all trig functions are positive here. Sine goes with this. Sine and cosecant, its reciprocal, are positive there. Take, that's tangent, tangent and its reciprocal, cotangent, are positive in the third. And calculus is the end of this mnemonic device, and the C stands for cosine, and its reciprocal secant are positive there. This concludes lesson 50 on trig equations.